Question number 7. 125 ml of coffee is poured in a well-insulated cup. The coffee is at 92 degrees Celsius, which is too hot to drink. So what volume of cold milk at 12 degrees Celsius would you have to add to reduce the temperature of the coffee to 72 degrees Celsius? Assume that the coffee and the milk have the same specific heat capacity of 4.184 joule over gram degree Celsius. So in this question, you have two different things. One is coffee and also the cold milk. So it means that the Q for coffee plus the Q for milk will be equivalent to 0 due to the law of conservation energy. So Q coffee plus Q milk shall be equivalent to 0, the law of conservation energy. So the Q is equivalent to ms delta T. So plus ms delta T is equivalent to 0. So you know that the mass of the coffee is 125 gram and the heat capacity is 4.184, and the T, the temperature, is the final temperature minus initial temperature. So the final temperature is 72, the initial temperature is 92. So this is ms delta T plus the ms delta T for the milk. So the mass of milk is the thing that you want to calculate. The S is the same, 4.184, just like stated in the question, and delta T is equivalent to 72 minus initial temperature is 12. Therefore, this is equivalent to 0. So you just need to calculate this thing and you shall get negative 10460 plus 251.04 m, which is the mass, is equivalent to 0. So this one bring here is equivalent to 10460. Therefore your m is equivalent to 10460 divided by 251.04. So you should get the mass is equivalent to 41.6667. Yeah. So since you want the mass, so the mass 1 milliliter is equivalent to 1 gram, so shall be 41.6667 grams. Moving on to question number 8. How much energy can be released during the following reaction if 2.5 liter of B2H6 and 5.65 liter of Cl2 both initially at STP are allowed to react? So given to you is this equation with the delta H equivalent to negative 1396 kilojoule. So since you were given the volume of this reactants, so you need to find the number of mole for each reactant. So since you were given the volume and also the temperature and also pressure, so you are able to find the number of mole for each of the reactant. So we are going to calculate the first reactant. So PV equivalent to nRT. So the first reactant is the B2H6. So given here B2H6, the volume is 2.5. So the pressure is at STP. So pressure shall be 1 atm, and the volume is 2.5. Is equivalent to N, the thing that you want to calculate. So R is a constant value 0.0821, and the temperature STP, so 273. So from here you will get your N is equivalent to 2.5 divided by 22.4133. Therefore your N is equivalent to 0.1115 mole of B2 H6. Right. So we are going to do the same thing for the second reactant, which is Cl2. So same drill. PV equivalent to nRT, where the P is 1 atm. The volume given in the question is 5.65. N is the thing you want to calculate. R 0.0821 and T, because at STP 273. Therefore, your N is equivalent to 5.65 divided by 22.4133. So you shall get your N is equivalent to 0.2521 mole of Cl2. Right. So from here, you are going to look back at the chemical reaction here. So 1B2H6 shall need 6 Cl2. So 1B2H6 will need 6 Cl2. So I'm just going to use the first number here. So if you have 0.1115 mole of B2H6, so how much Cl2 that you need? So you just need to 6 times 0.1115. So actually you should need 0.669, right? So mole of Cl2. So if you can compare between these two numbers, so you only have 0.2, but you actually need 0.6. So we can consider the Cl2 is actually the limiting reagent. Alright, since the Cl2 is your limiting reagent, we are going to look back at the question. So from the question, it states here that 6 Cl2 will produce this much energy. So 6 Cl2 will produce negative 1396 kilojoule. So how much Cl2 that you have? So you just have to bring it here. You only have 0.2521 Cl2. So how much do you need is negative 1396 divided by 6 times 0.2521. Therefore, you should get equivalent to negative 58.6553 kilojoule. So this is the final answer for this question. Question number 9. Given the following data, determine the rate constant for the reaction of NO plus Cl2 to produce NaCl. So in order for you to know what is the rate constant for this reaction, you first need to write the rate law. So the rate law is rate is equivalent to K, concentration of NO to the power of X times concentration of Cl2 to the power of Y. So you need to find the value of X and Y beforehand, then only you can find the value of K. So in order for you to find the value of X, we need to find the concentration of Cl2 that are the same. So we are going to use experiment number 1 and also experiment number 2. So we are going to use this formula. So experiment number 2 divided by experiment number 1, so 8.5 times 10 to the power of negative 5 divided by 3.4 times 10 to the power of negative 4 is equivalent to K over K, and the concentration of NO, which is 0.0150 to the power of X divided by 0.0300 to the power of X. and y is equivalent to 0.01 to the power of y, and this one is 0.01 to the power of y as well. Right, so from here it's easier for you to find the value of x, because this one you can slash, and then by using your calculator you can get the value. Here is 0.25 is equivalent to, this one is also the same, so you just need to divide this, so you shall get 0.5 to the power of x. Right, so 0.5 to the power of x is equivalent to 0.25. So what is the value of x? So you just need to put ln to this, so you shall get this one is x, this one because you want to get this one, so you get x ln 0.5 is equivalent to ln 0.25, right? So you can get the value of x, which is equivalent to ln 0.25 divided by ln 0.5. So your x shall be equivalent to 1.9999. So x is equivalent to 2. So we are going to use the same thing for finding the value of y. So in order for us to find the value of y, we are going to use the experiment number 2 and also experiment number 3. Okay, so the same drill, the experiment number 2 is the same, 8.5 times 10 to the power of negative 5 divided by experiment number 3, which is the same thing, 3.4 times 10 to the power of negative 4, but here the values are different. So 0.015 and this one is 0.015 as well to the power of x for each one, and the value of y are 0.01 to the power of y, and this one is 0.04 to the power of y. Okay, so from here the same drill, these k are the same and these have the same value, so you can slash it out. So this one, because it's the same value, you shall get 0.25, so it's equivalent to 0.25 as well to the power of y. So 0.25 to the power of y, if is equivalent to 0.25, definitely y is equivalent to 1. Okay, so from here, because you already have the value of x and the value of y, so you can plug in here. So the rate is equivalent to k and O to the power of 2 and Cl2 to the power of y. Okay, now only you can find the value of k. So how are you going to find the value of k is that you need to use any of the value from the table. Okay, so you have 3 experiments. You can choose either one of these and just plug in this formula, and then you shall get the value of k. As an example, I shall use experiment number 3. So we already know that the rate is equivalent to k and O to the power of 2 and Cl2 to the power of 1. So we just need to use the values from experiment number 3. So the rate in experiment number 3 is equivalent to 3.4 times 10 to the power of negative 4. So k is the one that you want to calculate. The value of NO is 0.015 to the power of 2 and the value for Cl2 is equivalent to 0.04. Right. So from here you shall get the value of K is equivalent to 3.4 times 10 to the power of -4 divided by 9 times 10 to the power of -6. So you shall get the value of K is equivalent to 37.7778. So this is the final answer for your 9th question.